Starting at A, do your feet get wet? No. But a little bit after what? A. Put your parentheses. That tells the reader a little bit after A. And then you keep going and you stop where? Well, really not at B because, yes, right before B because we don't include B. So we signify that with our parentheses. And again, if this is a more advanced algebra book, I guess, we can put parentheses here, parentheses here. So we have our graph, we have our interval. We just now need our what? Our set. So we say it's a set of all x such that, here's my description again. A less than x less than b. Okay? So this is a second type of scenario you can have. Do we have enough space over here? Maybe. What if I gave you another example and said, can you graph -3 less than x less than 0? We'll fit it in over here. -3 less than x less than 0. What does the graph look like? Let's do the graph. What would you guys write down? You guys notice is -3 smaller than 0? Okay, so put a -3 here on the left, right? Put a what? A 0. Put your open circles. You're kind of describing where those numbers would be. You're circling where they'd be. Now we have to describe numbers or shade numbers that are what? Between. Between what two numbers? What is x between? -3 and 0. Shade the numbers that are between -3 and 0. Numbers between are in the what? The middle. Do you shade these bubbles? No, why not? Because you don't see the equal. That's strictly less than. Strictly less than. Do you shade them? Why not? Because there's no what? Equality. Is that true? All right. What's the interval notation? What do you guys get for interval notation? What do you think? Huh? Parentheses. Good. -3 up to 0 and? Okay, good. Set notation. Set of all x such that this is your description. Good. -3 less than x less than 0. This is your description. So you're going to put this description here where it belongs in your set notation always, okay? So you got the graph, and again, you can have parentheses, interval, set notation. Yes?
I have a question. On the set notation at the bottom, is that always going to be an x? Even if like, the variable is different, like n or something?
No, it could be, if this is n, you replace this with what? N and n. If this is t, you replace this with t and this with t. That's a very good question. Because t represents an arbitrary real number again, and t will be between those two values. So it doesn't matter what letter they use. They like to use x in general. You see t, you see n, p, r, s. Change the letter. It doesn't have any real different meaning in terms of the process. Okay, you guys okay with that? You're looking at these forms. This is what I call the between forms. There's 4 of them. You guys have that in your notes? Okay. No? Not that one? Okay. Get that in your notes. I'm going to erase this briefly, this example. And I'm going to call this first one now, I'm going to call it number 3. And here we go with number 3. Let me see if you guys are awake. See if you guys could use your eyesight. Maybe I should have you guys all close your eyes. Close your eyes. Don't watch what I'm going to do or look away. Now you can open your eyes. Or you can take a look. Does anybody see anything different? What's the difference?
One is less than.
This is A is less than or equal to X. And what do you see here? Which means X is strictly less than B. Our X is between the two numbers A and B. In this case, X can possibly be equal to A. And in this case, what? X is not A. Let's ask you this question. Let's see if you're awake with this. Do I shade my A? Yes. Do I shade my B here? No. Oh, good. So what do I do?
Make it to
has to be a bubble or what? Good. You guys know this. So this changes my graph. It changes the interval notation. It even changes the what? Set notation. That's the only change. So for example, if they gave you, what if they gave you 1/2 is less than or equal to X, which is less than 4. And they wanted you to graph this between scenario. Right? Draw your real number line, for example. And you get what? 1/2, you get what? 4. Bubble the 1/2, bubble the 4. This is the location of where they would be. What do you guys notice? What do you guys notice? Does that equal 1/2? What should we do? Does that equal 4? So leave it bubbled. We got to describe numbers, shade numbers that are between these. Where are they? In the middle. Good, they're in between. Does that make sense? God, don't you guys just love how much sense math makes? It makes sense. Huh? All right, let's go back here. What was I talking about again? I don't even remember. Huh? Oh, math makes sense. Okay, we'll makes sense. Numbers that are in between 1/2 and 4 happen to be the numbers that are really virtually what? In between. Okay. What comes next? This is the graph. We got the interval. Good. So how do you describe this as an interval? Starting at what number are your feet wet? 1/2. Do we include the 1/2? So put a what? Good. Up to 4. Do we include the 4? Put a what? There's your interval. Set notation. Set of all x such that 1/2 less than or equal to x less than what? 4. Okay, you guys okay with this one? Anybody have any questions on this example of this in-between situation? Did you guys notice that on your homework?
Yeah.
What about close your eyes again now? Close your eyes or turn away. And let's see if you guys can find the last situation. All right, the last one. I'm going to call this situation number 4, or type 4. All right, now take a look at this. You guys notice a difference? What's the difference?
Do the same thing on the other side.
Oh, I did the same thing, but now on the other side? Is that true? What do you mean? Does not equal on the left, but what?
Equals on the right.
Okay. So if it's, well, that's not equal, so it's okay to not shade that bubble in, right? This is equal, so what do I have to do? Good, I shade that in.
Then include a bracket.
But then now, let's be careful. That's no longer a parentheses. You're right. That's a what?
Bracket.
Square bracket. Good. This is how this changes. Is everybody okay? Don't forget, that's my description. This is always the description. For your set notation, you always put the set of all, whatever the letter is, x. That needs to be less than or equal. You got to include the equality. So an example here could be, you know, they give you -11 less than x less than or equal to maybe, oh, I don't know, -6. So what happens now is going to be what's the relationship between -11 and -6? You guys notice which number is smaller?
-11.
So it's further to the left, right? Okay, good. Now what do you guys do? Shade everything, what? In between -11 and -6. Is that everything in between? All right. Do I include the -11? No. Do I include the -6? Yes. Shade that. What does your interval notation look like? Parentheses, -11, comma, -6, good. And then a what? Square bracket, good. And again, more advanced textbooks will have parentheses and what? Bracket. Set notation. Set of all x such that -11 less than x less than or equal to negative what? 6. So here you guys go. These examples here. So really what you're going to have is 4 of those between situations. There is no other. The first case is when they're both equal. The second case is when they're both not equal or less than, strictly less than. And then you have the other cases, the other two where one is less than or equal, the other is less than, or less than and less than or equal. So you get the other two cases here, and that's dealing with what we call a between. And so looking at your homework, there were some problems on your book. Anybody see that? There were some homework problems on your book that wanted you guys to graph and write interval and set notation here. So now you should be good to go with those what? With those problems. Yes?
Are you ever going to deal with greater than with intervals?
Say that again?
Greater than?
Not for between. Let's take a look at this in a little more detail. We actually look at this in a little more detail in intermediate algebra. But what this actually means is that A is less than or equal to X and X is less than B. So, I mean, you'll look at that in more detail in intermediate algebra, and I go through it with everybody. But no, the answer to your question is no. You're not going to have the inequality switching directions. Because this is kind of how it feels, right? Let's look at this example. We're trying to describe numbers that are really what? Between 1/2 and 4. In one case, X is smaller than 4. So we're shading numbers. Here's 4. Being smaller than 4 means you're talking numbers that are what? To the left of 4. But how far to the left we go? That's where the other number comes in. 1/2 has to be what? Smaller or equal to those numbers. 1/2 has to be smaller than the numbers we're describing. So if 1/2 is less than, that means 1/2 has to be furthest to the left. So that's why in some ways, I don't really emphasize reading it backwards because it could start to get a little weird. But if you really read it, 1/2 is a smaller value. 1/2 has to be less than the numbers. 1/2 has to be at the furthest left. X, or 4, has to be the furthest right value because all the numbers that are shaded have to be smaller than the 4. And if you wrote it that other way, you're going to see that there's some issues. Because then you have a smaller number and a larger, remember, smaller numbers on the left, larger number. So I don't want to open that can of worms for people. Because in all reality, this is a lot easier than you realize. And, and I say this, and I talked to my statistics class this morning, and I told them, about a process in statistics. What I find, you guys know what I find is, you guys anybody watch the movie Forrest Gump?
Of course.
What's amazing about that movie? Huh? Do you ever notice how he was able to do pretty much anything he wanted in some ways?